All right, in today's lesson, 7.3, which is on page 90, we will be looking at adding and subtracting rational expressions. And you just have to remember how you add and subtract rational numbers, hence the word fractions. Fractions are rational numbers. And so when you add or subtract, adding and subtracting has the pickiest rule of all the rules. In order to add and subtract a fraction, you need a common denominator. So you're not going to make this 3 over 8. What we're going to do is work to find a common number or a common multiple, usually called the least common multiple, for 3 and 5. So if you start looking at all the multiples of 3 and all the multiples of 5, you'll soon see that 15 is the first multiple that they have in common. So we're going to make a denominator of 15 for both of these. So the way we're going to start is to get this to 15, I would multiply the denominator and the numerator by 5. So that would become 10/15ths. And I would multiply this denominator and numerator by 3 to make 3/15ths. And then once you have the common denominator, it's still picky. You're only going to add the numerators because in the end you're describing how many 15ths you have. So this says I have 10, and this says I have 3, so I have 3 of these 15ths. All right? And the same would happen with subtraction. So here our least common denominator actually happens to be this number. So when I go for my common denominator, I don't need to change the second fraction. So to make this 14, multiply the denominator and the numerator by 2. So now when you're ready, 6/14 take away 1/14 means you have 5/14 left. And if you do have something like this, just realize that it's over 1. And now your common denominator would be 4, so the first fraction doesn't need to change. I would multiply this denominator by 4 and this numerator by 4, and then I would get 20/4, which ends up with -17/4. So the rule is common denominators. So this is a bit of a unique process. Let's see, let's kind of start out with, I'm going to jump around on this page with the order that I'm going to do these in. So I think the best one to start with is actually C. Okay, so what I'm going to do is first give this one a denominator of 1, and I now need both of these to be the same denominator. So it's really similar to this problem. And so if this is 1, I chose that denominator to be the least common denominator. So if this is 1, let's let x squared be the common denominator. So to get this to be x squared, I'm going to multiply the denominator by x squared and the numerator by x squared. So now I have my first fraction, which didn't change, and I have my second fraction, which is now 4x squared in the numerator and x squared in the denominator. And now what I'm going to do is add my fractions. So when you add or subtract fractions, the denominator is going to come along, and then I'm going to add these. Unfortunately, I can't make them 7 or 7x squared because they're not like terms. So I'm just going to write my numerator in standard form by putting the 4x squared plus 3. I am adding them, I just can't combine them into one term. So that's C. C is done. So the next one I think that we're going to take a look at is B. So the idea of B is this whole denominator is x plus 1, and this whole denominator is x plus 2. And so I need them to have a common denominator. So this one is really similar to this first problem. In the end, what I kind of did is I took this denominator times the other one's denominator, and I took this one times the other one's denominator, which is what will happen here. So what I want to start to show you now is sometimes it's really hard to see those common denominators. So what we're going to have to do is we're going to kind of back up here, and we're going to start making what I call the fraction table. I don't remember what name I gave it. And what we're going to have to do before we can do anything else is get these denominators factored. So 4x, I can't factor really. Well, I guess I could factor 4 down into 2 times x, and x squared I could factor into x times x. So that's that. This denominator, I can't factor this or factor this. This denominator, I cannot factor x plus 3, but I can factor x squared minus 9. So I'm going to factor that into a difference of squares because there's not a GCF. And so this has been replaced, crossing out the old denominator, putting in the new one. In this one, I'm going to start with this one because there is a GCF. I'm going to take an x out, and then I'm with x plus 4, which I can't factor this anymore. So this old denominator is gone, and I have a new version of it. And then this one, I'm going to factor for, I don't know how much space I'm going to need. So I'm just going to put my x here. I need factors of -4. There was not a GCF. That get me to 3. So that's going to be a 4x and a 1x, and I'm going to make the 1 negative. And so making my parentheses, dropping those x's in there immediately. X times x gets the x squared that I need, so that's good, and I guess you couldn't see that. And now I'm going to use these loops here to make these numbers. So since they're both x, they can make either one of these. So x times what makes the 4x, that would be a positive 4. And x times what makes the negative 1x? Well, that's a negative 1. I'm going to keep factoring. Let's get all this factoring done. The good news is I only have to factor the denominator. So in this problem, right, there's no GCF. I need factors of -14 that get me to 5x. So that's going to be a 7 and a -2. And then when I make these parentheses, let me move this up a little bit, I can go straight to my factors. And x, that's all I need because x and x make the x squared. And now I'll follow those loops to make the side numbers. And x with a positive 7 makes 7x, and x with the -2 make -2x. So I don't need this version anymore. And on this one, there is no GCF, so I need factors of -12 that get me 1, and that would be a -4 with the 3. So again, I'm going to make my parentheses. I'm going to drop my x's in there, but this time x's aren't good enough because x and x is x squared, and I need a 2x squared. So I'm going to give one of them a 2 now, because now 2x and x make the 2x squared. And now when I do these loops, which I'm actually going to write them in here, x can make both of these, but 2x can't. So 2x is the pickier one, so I'm going to start with that. And 2x can make a -4x by multiplying it with the -2. And that means I can multiply this x by a positive 3 to get 3x. And now I don't need this old version of the denominator. So some people have a really easy time seeing the least common denominator. Some people don't. So from here, I think the easiest way to do this is I think I'm going to start out with the toughest problem and work my way to the easier ones. So I do not have a lot of room here. I am using a separate piece of paper, and I would have normally provided more room, but these were not my notes. So what I do is I take the denominators and I make it, I call it the fraction table, and I take my first fraction's denominator and I put each factor, I'm going to make some columns here, and I'm going to put each factor into a column. So x minus 2 gets a column, and you can put them in parentheses. And x plus 7 gets a column. All right? Then I'm going to go to my second fraction, its denominator, so fraction 2, and I'm going to put this x minus 2 into this column. This column is going to be devoted all to x minus 2's. Now, with the 2x plus 3, it's not going to go here. This column is for x plus 7's. So what I'm going to do is give it its own unique column. Okay? So I don't know if I explained this very well, but this is a little technique to help you find the least common denominator. It really does work. And now what I'm going to do is to find my final denominator. So final denominator, I'm going to drop everything down. So x minus 2 comes down, x plus 7 comes down, and 2x plus 3 comes down. So when I'm done, I need for each fraction to have all 3 parts. Okay, so when I look at my first fraction, it has the x minus 2 and the x plus 7, but it doesn't have the 2x plus 3. So what I'm going to do is take this fraction and multiply the bottom by 2x plus 3, just like I went up here and I multiplied this by 2, but whatever we did to the bottom, I did to the top. So I'm going to put this 2x plus 3 also on the top. Now when I look at this fraction's denominator, it has the 2x plus 3 and the x minus 2, but what it doesn't have is the x plus 7. So I'm going to take this one's fraction or denominator and put an x plus 7 on the bottom, and whatever I do to the bottom, I do to the top. All right, so we're going to pause on problem F, and again, what I want to focus right now on is just finding the least common denominator so we can add and subtract these fractions. So for problem E, I'm going to go ahead and make another one of these fraction tables. So here's fraction 1, and each factor is going to get its unique problem. So this one gets x minus 1, and another column for x plus 4. And then I'm going to go to the second fractions denominator, and this x plus 4 can join this x plus 4. But x is a whole new factor that's coming in, so it will get its own unique column. And now, to get my final denominator, I'm going to drop everything down. So each denominator will need an x minus 1, an x plus 4, and an x. So when I look at this fractions denominator, it has these two things, but it doesn't have the x. So I'm going to multiply, I'm going to give the denominator an x, and whatever I do to the bottom, I do to the top. When I look at this one, it has the x and the x plus 4, but what it doesn't have is the x minus 1. So I'll give this denominator an x minus 1, which means whatever I do to the bottom, I do to the top. So we're going to pause there. We're just working on finding common denominators. Now the next one might be a little easier to see. When I go to my first fraction, it only has the factor of x plus 3. When I go to my second fraction, it has the x plus 3, which can double up here, but it doesn't have an x minus 3, so it's going to get that unique column. And then to get my final denominator, I'll drop these down, and I'll need to make sure that each fraction has these two things. The good news is this one has both of them, so I don't need to change this fraction. But this fraction has the x plus 3, so it needs the x minus 3. So I'm going to put one on the denominator, and whatever I do to the bottom, I'm going to do to the top. All right, let's keep walking through this. B then, hopefully you're going to be able to see this. The more we do these, we start out with the tough ones. First fraction only has x plus 1. Second fraction only has x plus 2, different factors, different columns. And then when I drop everything down to get my final denominator, each one will need both of these. So this one has the x plus 1, but it doesn't have the x plus 2. So I'm going to give it to the denominator, and whatever I do to the bottom, I do to the top. And this one has the x plus 2, but it needs the x minus 1, so whatever I do to the bottom, I do to the top. All right, the last one. So I did break this down, and sometimes, this is a simple problem, but I feel like the simpler problems become the tougher problems. So this is why I broke down the 4. So fraction 1 will have a 2, and an x. And then the second one, I can put one of the x's to join this x, but the other one will have to get its own column. So now I can drop everything down to get my final denominator. And now I'll need to make sure that both of them have 2 2's and 2 x's. So this one has the 2 2's, but it only has one x, so I'm going to give it another x, and whenever I do the bottom, I do to the top. And this one has the 2 x's, but it doesn't have the 2 2's. And when I put 2 and 2 there, that's the same as putting the 4, so whatever I do to the bottom, I do to the top. So now what we've done is we've already gotten our common denominator. So starting with A, let's start to finish these problems. In the end, I know that my final denominator will be 2xx, or 4xx. And I'm going to write it the most simplified way here, because I can on that one. It's just going to become 4x squared, because that's 4x squared, or that's 4x squared. So final fraction, final denominator. Now what I'm going to do is put a little n here to just show you the work that I'm going to do in my numerator. So in this numerator, remember, when we put these numbers in here, we're multiplying them like we did up here. 2 times 3, 5 times 4. So this is all multiplying. So 3 times x is 3x. Here I'll do 5 times 4, which is 20. And then my goal is always to simplify it as much as possible, but 3x and 20 aren't like terms, so I'm going to leave it as 3x plus 20. And now that one's done. When I go to this problem, again, I already got that final denominator. It's x plus 2 and x plus 1. Or I could look at here, x plus 2 and x plus 1. So I'm just going to write it, bring it along. And now all my work's going to be in the numerator. Because again, up here, once we got our denominator 4, it went along for the ride. All the work happened in the numerator. So here's my numerator work. Here's n for numerator. And this will be an x times an x plus 2. And this will be a minus 3 times an x plus 1. So now I need to simplify this. So the first thing I'm going to do is divide this in, or multiply it in, multiply that in, distribute. And now I'll just clean this up. So I can make this x squared minus 1x minus 3. And then that's it. We are going to leave it like that. That's all my work for the numerator. So the next one, oh, we already did that one. All right, so let's go to D. So D, I'm ready, I'm going to get my denominator set. It's x minus 3, x plus 3, x plus 3 minus 3. So I'm just going to leave it like that. Whoops, you can't see that. And now I'm going to put the work into my numerator. So here goes my numerator work. Remember, these are multiplying, so it will be 4 times x minus 3. The second fraction I didn't have to change, so I'll just put a plus 2. Now I'm going to simplify this, so I'm going to distribute. And then I'm going to combine these, and I'll get 4x minus 10. And that's great. Fraction done. Let's go to E. So on E, again, I got my denominator. I already know what it is. Either way, it's x, x minus 1, x plus 4, x, x minus 1, x plus 4. So I'm just going to write it. You can write these in any order you want. And now for my numerator work, okay, this is going to be an x times an x. Well, I'm going to go ahead and just make that x squared. And then this one's a tricky one, because this minus means I'm subtracting everything in here. So you got to be really careful with this. So what's going to happen is I'm going to actually go to this problem, and I'm going to turn this problem into a addition problem, and I'm going to add, and then I'm going to take the opposite of this term and the opposite of this term. So right now you should see a positive x, and I'm going to make it a negative x. And then when I see a negative 2, I'm going to make it a plus 2. I'm just doing the opposite. So now when I go to here, I have a plus, which we'll be able to work easier with, and I'm going to take these parentheses, which is negative x plus 2, times these parentheses, which is x minus 1. So now to simplify it, I will have to multiply here, have the neighbors meet the neighbors. So I'm going to get a negative x squared, a positive 1x, a positive 2x, which I'm going to write side by side this time, and a negative 2. I'm going to drop down this positive x squared, and then what you're going to see happen is this x squared and this negative x squared will cancel each other out. 1x and 2x is 3x with the minus 2, which I can't combine because those aren't like terms, and that one's done. F is going to take the most work for the numerator. So I'm going to put my denominator all the way down here because I really don't know how much work I'm going to need. And either way, either denominator is 2x plus 3, x minus 2, x plus 7. So I'm going to write those down. You can put them in any order you want. And now I'm going to put the work for the numerator up here. So here's my numerator work. So the first one, I'll have to take 2x plus 3 times x plus 4. Here's that plus sign in between. And then over here, I'm going to take x minus 3 times x plus 7. And I know this is a lot of work. I feel you here. All right, so neighbors meet the neighbors, distribute. So I'm going to get a 2x squared. I'm going to get an 8x. Then I'm going to get 3x. And then I'm going to get 12. So here, I'm going to get 2x squared plus 11x plus 12. Now I'm going to have the neighbors meet the neighbors here. X squared plus 7x minus 3x minus 21. So here comes that plus, just dropping down. X squared, this is 4x, and this is minus 21. And now I'm just going to keep going by combining like terms. So the 2x squared and the x squared can make a 3x squared. The 11x and the 4x can make a 15x. And the 12 minus 21 can give me a negative 9. And then we're done. That was a lot of work for that problem. And that is adding and subtracting rational expressions. And that's it for those notes.